So now the topic is compressed air systems and pneumatics fundamentals. So i-mix na natin to. So this is the compressed air system. Ito yung pneumatic system mo. Ito yung naman compressed air plant system. So main component yan is yung compressor. Then lalabas siya papunta sa ito inlet to inlet. Then, after cooler, then punta dun sa dryer, then air filter, air receiver, then punta na dun sa system mo. Yung system mo, meron po sa mga filter regulator, lubricator, kasi dapat malinis yung compressed air mong lumalabas. Okay? May kanya-kanyang quality yan. Depende sa application mo. Pag sa tools, medyo baba lang. Pero pag sa mga instrumentation rooms, yung high quality. Okay? Sa ating control panel, sa electrical niya. Compressor NN, lubricant air separator. Yan ang mga parts ng compressed air system. So, ang design ng compressor normally is naka-loop at yung take-off niya is nakataas din kasi iniwasan nga yung moisture. So, para yung moisture maibaba niya. Normally, sa ibang design, every naka-slope yan, every point yan, may drains. Okay? So, kaso magastos yun. So, kailangan pipili ka na lang ng ibang point or idadry mo yung high quality yung dryer mo. Okay? Ang dryer, maraming klase. Compressor, maraming klase. Sizing, later, dito sa discuss natin yan. So, plant air consumption. Ano yung size ng plant, compressed air plant mo? So, siyempre, depende sa requirements na building mo. Okay? So, the main consideration in the selection of compressor plant is the production of an adequate supply of compressed air at the lowest cost consistent with reliable service. Hindi ka pwedeng mag-overdesign dito kasi ito yung pinaka-mahal. So, the installation of a compressed air system, as with all forms of power transmission, calls for capital investment with consequent operating and maintenance costs. The information on which the selection of plant is based should be as accurate as possible. So important factors to be considered are the following. So the operating pressure, discharge pressure mo. Lahat naman kasi kahit sa plumbing, sa gripo, may required pressure yan. Okay? Dito, mga outlet, may required pressure yan. Okay? Maximum and average load, use factor, future expansion, yan. Allowance for air leakage. Silosis yan eh. So, use factor, yung hindi naman kasi lahat sabay-sabay. So, gagawa ka ng use factor para lumiit yung compressor mo. Okay, yung iba kasi nag-design drawing lang, lagay ng pipe size. Hindi nila naisip yung pressure doon sa outlet. Tawag doon yung mga residual pressure or operating pressure. Normally, ang residual pressure doon sa outlet, ang operating pressure sa compressor, pag sa compressor is compressor. Pressure ng compressor. So, plus yung mga losses, so yun ang magiging outlet mo. Plus, unless may mga losses, so yung remaining is yung residual pressure mo na dapat above doon sa required. So, the operating pressure. So, most compressed air equipment operates at 6 bars gauge. And it is usual for the compressor to deliver air into the mains at 7 bar in order to allow for transmission losses. So, tables 1 to 4. If some of air is to be used at a lower pressure, for example, for instrument control, the pressure is reduced by means of a pressure regulator to the required line pressure. Huwag ka mag-alala, may sarili ng regulator yan. So 7 bar is convert mo mga 100 PSI yan pa yan. Okay, that is 100 PSI. So nakuha ko lang reference is SI. Pwede rin kayong humanap ng ibang reference as in the future para sa pag-design nyo. So dito, ito lang kasi nakuha ko medyo maganda-gandang discussion. yung binigay ko sa inyong reference. Gusto magparahanap pa. So ito, convert nyo na lang yan. So ito yung table 2. Table 1 muna tayo. So maximum recommended flow through main flow. So ito yung maximum flow. So velocity of airflow must be restricted to less than 6 meters per minute as shown if carryover of moisture past drain legs is to be avoided. Yan. So, pag gusto mong wala yun. Pag mababa, pag mataas, so kailangan mo. Medium weight steel tube to BS 13987 sa equivalent niya. Yung BI5. Yun. So, velocity. So, kahit wala to, makakapag-design ka, basta ano mo, velocity mo is less than 6 meters per second. Okay? So, based on 6 meters, ito yung nakuha niya value sa standard size. Take note, nominal bore in mm. So, gamit tayo ng SI. Ang equivalent nito is ito yung 1/4. Dito 3/4 sa 10 mm. Ito 1/2. 3/8. So, based tayo sa, this is 3/4, 1 inch, 1 1/4. So, alam niyo yung equivalent, diba? So, 50 mm 2 inches, 65. So, ito yung standard na conversion sa SI. Hindi yung 2 inches, naging 50.8. Yung language mo dito, 51. Ang tawag ito is nominal. Wala kang problema. Equal yung conversion. 65 mm. Kapag kinonvert mo yung 2.5, yung statistics is 2.5. So, yung nominal, 65. Yung katapat, itapat-tapat mo lang yan. So, 80 is 3 inches. Yung iba gumagamit ng 75 or 76. Okay? 100, 4 inches. So, 125, 5 inches. Dito 6 inches. Hindi sa 122.4. Okay? So, hindi niya pa kabisado kaya ini-explain ko. Actual bore, so walang problema to. At least sa diameter. So, ito na yung rate of airflow at 7 bar. So, at different pressure, so meron tong formula. Alam mo na yung ideal gas, di ba? Makuha mo yung equivalent. This is liter per second. So, i-convert nyo lang to sa CFM. Kasi minsan, CFM yung value na gamit. So, this is the maximum recommended flow through branch line of steel pipe. So, branch line. Andito kasi siya. Maximum recommended airflow liter per second of free air through medium series steel pipe for branch main not exceeding 15 meters in length. The flow values are based on maximum recommended peak flows. So yan, masahin niya lang yan. This is naman to sa mga branch line. So ito yung mga pressure niya. And this value is for free air. Free air liter is ito yung sa ambient na equivalent ng liters per second. Hindi ito sa actual pressure niya. Okay? Pag ito, sinabi niya, rate of airflow at 6 bars. So, at 7 bars. So, at 7 bars siya. Pag pinabing free air, so, at ano siya, atmospheric pressure. So, later, discuss natin. Yung CFM equivalent at, o liter per second equivalent at, ano, ambient, atmospheric. Okay? Applied pressure selected compressor. Ito yung mga applied gauge pressure. Is doon sa piping mo, so i-estimate mo kung ano yung nandiyan na kasi nag-reduce yun from main to the outlet, nag-reduce siya. So dito mo na ma-estimate yung pipe size. So hindi tayo gamit yan gamit tayo ng velocity. So at least, in-explain ko itong value nito. So ang value niyan is in free air, atmospheric pressure and temperature. So convert ko siya. Table 3, pressure loss through steel fittings, equivalent length, pipe length. So ito naman, alam natin yung equivalent length. Application yan, di ba? Ina-add sa fittings. This is for steel. Ito naman, pressure loss through ABS fittings, equivalent pipe length. Isa itong material ng pipe other than steel. So ito naman sa mga, equivalent pipe length. Okay? Open mo dyan. Ito yung 90 degrees lang. This side, outlet of T. Yeah. So all equipment connected to the system shall either have a design pressure greater than the maximum output pressure of the compressor, or special precaution should be taken to ensure that if its design pressure is lower than the output pressure of the compressor, it cannot be subject to excessive pressure. If there is a requirement for a large volume of air at higher or lower pressure, it may be more economical to install a separate compressor to deal solely with that. India niya. Okay, all equipment. Rating to ng equipment, design pressure, maximum pressure ng equipment. O design, maximum design pressure ng equipment. Hindi yung operating. Sabi nyo, nagre-reduce tapos maximum greater. So, hindi. Yung design pressure mo rin ng mga equipment mo dapat above din sa maximum output pressure of the compressor. Kasi ito, ang pressure mismo yung body niya sa pump din. Okay? So, ababa, or higher than ano naman, sabi dito, mag-separate ka ng compressor para yung compressor mo, siya lang set nun. Kung mababa sa compressor mo. So, meron kang isang separate na pressure para lang sa mababang pressure. So, maximum and average load. So, meron tayong, sa usage, meron tayong, minsan malaki ang ginagamit natin, minsan mababa, so meron tayong average na tinatawag. So ideally, the total capacity would be based on exact knowledge of the equipment or process equipment. May mga table naman yan sa brochure. If this is underestimated, the compressor plant will be too small and will be unable to maintain the required pressure in the system. In effect, conversely, if the total air consumption is greatly overestimated, there may be excessive capital investment. So, awa ka naman sa client. Pinatiniwala sa iyong design, in-over-design mo naman para matapos mo yung ginawa mo, tapos mabayaran ka. Hindi naman alam ng client na yun ang paggawa mo. So, furthermore, any arrangement which results in significant offload running waste energy. Furthermore, any arrangement which results in significant offload running waste energy. Yung mga sayang. However, it is safer to err on the high side with a slight overestimate, slight lang, as in most installation, the use of compressed air will increase and soon take up any surplus capacity. Mga extra uses lang. So, tama lang. Use factor. So, ito. Before deciding the capacity of the compressor required, it is necessary to calculate the air consumption as expected. It is recommended that reference is made to Table 5, which show typical use factor for various types of pneumatic equipment. In some cases, where there is experience of a similar installation, plotting data obtained from past activity can make accurate analysis. Nasa may, ano ka, so, sa planta ka na ikaw ang operator, may record ka ng mga consumption, so gusto mo mag-additional, so may record ka ng mga consumption. So, this is example. Table 5, air consumption of pneumatic equipment, example of calculation. So the following calculation is typical of a medium-sized engineering workshop, including a foundry, where a high degree of mechanization is to be carried out by means of compressed air-driven machine tools and tools. Listed in the table are the tools and other pneumatic devices which are expected to be included in the installation at full production capacity expected. The use factor of different tools is calculated in connection with production planning, and thus it is possible to establish the average total air consumption. Dito is based to sa production planning. Nilagay lang to ng mga tao noon kasi yun ang ina-expect nila. So, machine or tool, air consumption per liter, sa liter value. Second, quantity, maximum air consumption, use factor yan. Average air consumption. So, sa foundry, meron siyang core shop. 1. Merong 4 blower, ang consumption is 11 meter per second, quantity is 3. So maximum air consumption is yung total niyan, magiging 33. Use factor, multiply 0.5. So, gamitin ng 0.5 is 16.5. Kasi tatatlo lang siya. So, ibig sabihin, pwedeng isa, may nagamit, dalawa. So, in average, ang use factor na is 0.5. So, bench rammers, 4, tapos dalawa, so 10. So, ang use factor mo is 2. So, is 2.0. Okay? Sa bench hammer kasi, variable pa yung consumption mo. This is the maximum. Para sa amin, dalawa. Huwag isa, dapat 50%. Hindi. Sabihin nyo, yung air consumption mo, rating niya. Next, sa isa naman kwarto, meron kang machine molding, 2. So, molding machines is 12. This is 8. Logans 8. Air hoist, 100 kg, 30T. Consumption niya, liters per second. Quantity is 5, 5, and 2. Maximum air consumption, 12 times 5 is 60. 8 times 5 is 40. 33 times 2 is 66. So, total of 166. The use factor, molding machines, so this is 0.3. Logans, 0.1. Air hoist, 0.1. Biro lang gamitin. Okay? And yan. So, consumption is 18 for 6.6. This is now 28.6. And sa hand molding, room naman, rammers, medium 6, 1, 6.2, 1.2. Yan. And meron pa ito. So, ang total niya, ito yung mga use factor. So, ito na yung maximum is 81. Average air consumption is 10.5. Same sa cleaning shop. Ganun din. Ito yung mga equipment. Quantity and maximum air consumption naging 410. So, this is now the average air consumption is 150.5. Baba, di ba? So, ikaw magtatansyan yan para sa design mo. Total for foundry is 700 maximum air consumption liters per second, and the average air consumption is 178 liters per second. Baba. Next is sa workshop, the same din lang yan. Ito yung mga gamit mo. So, gagawa ka ng tabulation. Yan. So, hanggang ito. Yung mga gamit mo. Okay? So, dito, may idea ka na ng mga air consumption per unit. Kaya pag nagtrabaho ka, so balikan mo itong lecture o yung libro, kita mo doon yung mga value. Eh, hindi ka na magtanong, ilan bang consumption ng grinders? Yun. So dito, makikita ka na. Wala kang input from the supplier o sa catalog. Okay? Future expansion, allowance for air leakage. So, future expansion should always be taken into account when installing new plant. Increasing compressor capacity presents no problem if the rest of the plant installation has been planned accordingly. So, meron kang spare space para sa extra compressor mo system. Experience has shown that the initial estimate of the total compressor capacity should include an allowance for leakage. So leakage in the pipelines can be overcome by proper installation practice. So a large production or proportion of the total leakage occur at hoses, couplings, and valves. For installation with regular inspection and maintenance, a factor of 5% minimum should be adequate. So na-compute mong average consumption, so multiply mo pa ng 1.05, so yun na yung compressor capacity. Okay. So yung iba, na-i-estimate nila kasi para pare-pares lang malabas. Pero mas maganda na rin, meron kang detailed plan. Plano yun eh. Itong binasok mo capacity, itong ginamit mo, itong nakalagay na quantity. So lalabas nun, detailed ang ginawa mo. Designer ka. Hindi ka yung yung nagtsamba-tsamba lang kasi nakakaya ng iba yun, ibang field, ibang engineering field. Kasi nire-ratio lang nila yun. So, hindi dapat yun. Kaya ngayon nga, nire-require na yung mga analysis. Kasi kung walang analysis, pagdating ng inspection nila, hindi na maisusulit yung equipment kasi mali. Diba? Yung mali equipment, mayroon na isuli yun. Okay, now selection of compressor plant. So for the egg compressor, ito yung mga types and their basic characteristic. Sa figure 1, meron tayong types based on dynamic and displacement type. Dynamic, andito yung projector, may velocity, radial, and axial. Then sa dynamic and sa radial, meron tayo sa rotary. Sa axial, so, hindi, mali. Dito yun. So displacement type, meron tayong reciprocating, yung may piston, trunk, closed-head, labyrinth, diaphragm, ito yung mga type niya. Rotary. Rotary is also displacement, and ito yung vein type, liquid ring, screw. Yan. One rotors. Two rotors, meron tayong screw at roots. Tawag yan mga rotary type. Umiikot lang. So, pag dynamic, andito yun. Radial, yung mga centrifugal. Diba? Axial. Kino-compress, kino-convert sa pressure. So, positive displacement compressors units are those in which the successive volumes of air are confined within a closed space and elevated to a high pressure. The capacity of a positive displacement compressor varies marginally with the working pressure. Reciprocating compressors, here the compressing and displacing element, piston or diaphragm, has a reciprocating motion. The piston compressor is available in lubricated and non-lubricated construction. Yung mga luma old-style design. Next, the helical and spiral loop compressor or screw. So, rotary positive displacement machine in which two intermixing rotor, each in helical configuration, displace and compress the air, available in lubricated and non-lubricated construction. The discharge air is normally free from pulsation. This is high-speed rotation. Next is the sliding vane. Ito yung vane, may slide. Umiikot siya, so compress niya. Rotary positive displacement machine in which axial vanes slide radially in a rotor mounted eccentrically within a cylindrical casing. Available in lubricated and non-lubricated construction. The discharge air is normally free from pulsation. Ang topics na compressor sa gas is an extension ng fluid machinery. Sa fluid machinery kasi, alos 90% discussion doon is for water. Pero kung mabasahin nyo, hanggang sa yun, sa steam, gas turbine, ayun, kung machine ang discussion doon. Hanggang dito sa compressor. Ito yung mga types. Diba? So, fluid machinery na concentrate lang kasi sa water. Okay. Two impeller, straight lobe compressor, and blowers. So, rotary positive displacement machine in which two straight mating but not touching impeller, lobe impellers trap the air and carry it from the intake to discharge, non-lubricated. The discharge is normally free from pulsation, low pressure, high rotation speed. For dynamic compressors, these dynamic compressors are rotary continuous flow machines, ayan, in which the rapidly rotating element accelerates the air in rotary as it passes through the element, converting the velocity head into pressure, partially in the rotating element and partially in stationary diffusers or blades. The capacity of a dynamic compressor varies considerably with the working pressure. Next, the centrifugal compressor. Acceleration of the air is obtained through the action of one or more rotating impellers and lubricated. The discharge air is free from pulsation, very high rotation speeds. Ito yun. Next, the axial compressor. Acceleration of air is obtained through the action of bladed rotor, stator, so fixed, and the rotor blade, rotary, shrouded at blade angle end, and non-lubricated, very high rotation speed, high volume output. For the capacity and pressure limitation, see figure 2. Kadalasan ganito makikita mo sa mga supplier na sa catalog, supplier's catalog. Selection ka. Alin doon, gagamitin mo. So, pag pumasok sa range, yun ang giging selection mo. So figure 2 shows the approximate capacity and pressure limitation of each type of compressor. So pressure and the capacity in liters per second. There are areas where more than one type of compressor will provide the required capacity and compressor. In such cases, other characteristics such as those given above and the type of and pattern of use will govern the selection. Consultation with the supplier is advised. Pwede mo lang natin yan. Yan. Bawa, 1,000 liters per second. Ang pressure mo is nasa, this is a logarithmic scale, So this measure mo nito, log scale to, ito log scale din. Okay? This is 10, 20, 30, 40, 50, 60, 70, 90, yan. So 20, 10, 20, 30. So 30 pesay, tapos 1,000. So dito ka tumapat. So ang pipiliin mo is centrifugal or the reciprocating. Kasi pareha sila pumasok yan. Okay? Sample lang yun. At ang pagbasa nito, this is equivalent to 1, 0 to 1. So ito, wala to kasi wala namang logarithmic at 0. Dito tayo, log of this is equal 1, ito 1. This is equal distance naman yan. So, ibig sabihin, logarithm of 1 is 0, logarithm of 10 is 1, logarithm of 100 is 2, logarithm of 1,000 is 3, logarithm of 10,000 is 4. So, i-convert mo sa 0, 1, 2, 3, 4. So, doon ka mag-interpolate kung gusto mag-interpolate sa graph. Nakita mo dito 1 to 2. So, dito na tayo. 0 to 1. Dito ka sa kalahati. So, that is lalagay mo 0.5. Kasi 1, 0 to 1 yung anong mo. So, this is 0.5. So, the anti-log mo, makukuha mo yung value dito. So, ano anti-log ng 0.5? Three, di ba? 3. So, this is 1, 2, 3. 0.2. So, yan. Tama, di ba? Ganun ang yung pag-interpolate sa graph. Okay? Huwag mo tantahin. This is, andito ka, ginawa mo is 1 to 10 is times 4.5. Yung average mo. So, hindi siya 4.5, kundi 3.16. Diba? Ang actual value ng gitna niyan. Hindi mo siya i-average para maging 10 plus 1 divided by 2 is 5.5. So, hindi siya 5.5. 3.16 siya. Okay? Kasi nga, dito mo sa interpolate sa 0 to 1. Anti-log mo, yung 0.5, makukuha mo ito. 3.6. Compressor standby capacity. On many installations, it is normal to plan the number of compressor units in their output so that there is a standby capacity to permit one unit to be shut down for servicing. So where a constant supply of air is essential to operation, standby compressor are necessities. So kung complete mo isang compressor ka lang, so maganda ka pa ng isang compressor na standby. Kung malaki yung compressor na compute mo, hatiin mo para maging tatlo yung compressor mo. Yung isa standby, yung dalawang hinapin mo, yun ang operating. Okay? So, alam mo, makakatipid ka sa isa. Okay. So, load splitting, in all installation, consideration should be given to have at least 2 compressors to allow for conditions of live load and for maintenance. So, yan. Minimum of 2. At least 2. Closed loop systems. The same general consideration listed above apply to 2-level closed loop system, but the required input to the compressor will be considerably reduced or a smaller compressor can be used. So, closed loop system, the same consideration, sabi nga, which is for two-level closed loop. So, sabihin, one compressor, tapos meron kang loop, tapos sa loop na yun, nag-out ka pa, tapos may isa ka pang loop. So, doon, mas mababa yung compressor mo. Reduce. Kasi nga yung diversity factor. Tapos, kaya lang, siyempre, yung piping system mo, malaki. Output control, so meron tayong control dito. So, ito yung control system ng control compressor. Because there are wide range of controls available to match compressor output to demand. Consultation with the equipment supplier is essential. The output of a compressor can be controlled by several methods as outlined below. So dito, pneumatic, hydropneumatic, and electronic devices can perform the following functions. So bigay natin sa atin yun sa mga pinukuha ng ano yan, yung mga ECE. Sa BMS, sa electronics, yan. Yung nagiging kaagaw ng mechanical yan. Bibigay ka lang ng function. So, the reciprocating compressors, right, nadoble lang tayo. So, ito. So, reciprocating compressor, ito yung, ano yan, function. Intermediate operation using automatic stop-start mechanism. Constant speed running with inlet valve blocking or intake throttling or external bypass of inlet valve unloading or zero socket. And variable speed. All or combination of above. So, rotary sliding vent compressor, meron na tayong intermediate operation using automatic start mechanism. Yan, meron din naman constant speed running with inlet valve blocking or intake throttling or external bypass. Then, variable speed, minimum rotational speed must be high enough to ensure that the blades remain in full contact with the stator. Next, sa rotary screw compressor, meron tayo constant speed running with external bypass or intake throttling coupled with blow up to atmosphere, and also variable speed. So, dynamics, compressor, these are constant speed. Meron tayong constant speed running with intake throttling coupled with blow up to atmosphere. Meron naman tayong variable speed. So, advice should be sought from the supplier as to the best type of control to suit a particular application. So, may trabaho na kayo. So, selection of compressor prime mover. Ano yan? Yung motor, example. So, meron tayong an important factor in obtaining an economical plant is the selection of an appropriate compression drive. The most common power units are the electric motor, engine, the diesel, petrol, gas, etc. And the turbine, with the gas, steam, etc. So among the advantages of electric motor drive are compactness and ease of control. So the internal combustion engine is prepared for mobile units, emergency standby units, or where electric power is not available. A turbine drive is prepared where it helps balance the energy system of a plant, or where the steam or gas can be further used. Ang extension niya, yun nga, alternative. This type of drive permits easy speed control and conserves energy. So, kasi output nyo na yun sa product nyo ng steam, so gamit nyo dito. Regardless of the type of prime mover, professional advice should be taken in matching prime mover to compressor. Kahit yung reference natin, nag-suggest, mag-refer lagi sa supplier. Isa na yun. So, application requirements. To avoid delays in the preparation of estimate and unnecessary expense for both buyer and supplier, it is important that all necessary data should be available and recorded. The parameters that must be established are outlined below. The compressor output conditions. The volume of free air required liters per second. Isa 1. The minimum discharge pressure required to maintain an acceptable working pressure at the point of use. Yan sa outlet. Quality of air, degree of cleanliness required. Later, kasi dyan mo kasi malaman kung ano yung gagawin ng dryer. The purpose for which the air is to be used. Instrument, mga tools, and the pattern of the demand for air, continuous or intermittent consumption. Estimated operating hours per day or week. Per day and a week. Yan. Type of control. The need for an air receiver. Any special conditions which the compressor must satisfy. Requirements for ancillary equipment, for example, water pump, valves, piping, anti-vibration mounting, after coolers, dryer, intake filters, and silencers. Example number 1. Pagkuha ito ng total capacity. So, service, tap tools, ito, quantity 2, type tool, equipment, impact, rest, report, ang CFM soda. Sa CFM naman tayo. Ibang reference na tatang tinuhanan ko. CFM total. 2 times 7. So, yan ang mga, ano mo. So, this is a different approach. And then yung mga equipment. Total CFM and service, 80. Total CFM required for all tools, equipment, listed 100% duty cycle is 80. So the total CFM is 80 CFM times 0.7 is the duty cycle is 56. So mataas ang duty cycle niya. The tools. Ano siguro sabay-sabay ito. Normal operation niya sabay-sabay. Okay. Sa isa kasi itong area. Note all above tools equipment operate at approximately 90 to 100 psi except tire changer and in-ground flip, which will operate faster and more efficiently on pressure up to 150 psi. So may dalawa dito. Ito sa katumatas ang pressure. Okay? Yeah. Ito ang total ano mo. So mag-iiba ka na. May reducer ka doon sa iba. Okay? So, mangyayari dyan, yung system mo, ito yung total capacity mo, tapos mag-operate ka sa 150 PSI. Pagdating dito sa equipment, mag-reduce ka na. Okay. Example number 2. So this is a thermodynamic example. So wait, walang solution. Ayusin natin ito. So example number 2. So balikan lang natin yung termo nyo. Okay? Hindi naman sinabing, ito lang tinuro ko. Pagdating sa exam nyo, iba-iba na. Sabihin nyo, hindi naman tinuro. Doon naman talaga, hindi ko naman ituturo yun. Kasi tinuro na sa inyo. Diba? Sa higher subject na tayo, hindi na kailangan ituro yung mga ibang topic about dito. Okay? Yung mga intercooling, pinapa-review yun sa inyo, binibigay sa inyo pinapasolve sa inyo yun para mabalikan nyo. Pagdating sa board exam at alam nyo rin sagutin. Maituro sa inyo o hindi. So dito, ibabalik natin through exam or through example. Parang tulad dito. Okay, gamit ito kasi. So a single acting air compressor operates at 150 RPM with an initial conditions of air at 97.9 kilopascal and 27 C. In discharge the air at 379 kilopascal to a cylindrical tank. The bore and stroke at 335 mm and 381 mm respectively with 5% clearance. If the surrounding air is at 100 kilopascal and 20 C, while the compression and expansion process are PB exponent 1.3 is equal to C, determine the free air capacity in cubic meter per second. So dito maintindihan nyo kung ano yung free air. Free air based dito sa atmospheric or surrounding air. Eh, hindi sa inlet, hindi sa attic, kundi may isang reference point siya. Yung tawag na free air capacity. Hindi sa yung actual na ganito ang pressure, ganun ang labas ng air. Okay? So, ibig sabihin, reference point niya is para pare-parehas yung specification ng compressor mo. At any pressure, bibigyan niya is free air. Okay? Given, piece of 197.9 kilopascal, hindi ko na i-drawing yung cycle kasi di naman kailangan dito. Piece of 2 is 379 kilopascal, N is equal to 150 RPM. Piece of 1 is 27 C, piece of F is 20 C, piece of B is equal to 100 kilopascal, EB is 1.3 is constant. Required piece of F is the free air capacity in cubic meter per second. Okay? Balikan niyo yung mga compressed air compressor topics, dapat na dun sa reviewer nyo. Marami doon. Okay? Kaya dapat napag-aralan nyo rin ito ng thermo. Yung thermo. Ito yata, one. For solution, for a constant mass flow, ito yung formula mo. Mass flow rate is constant. So, piece of F over piece of F. Ito yung atmospheric mo. At the surrounding air is equal to P1 B1 over T1 sa initial condition of air. Diba? Itong temperature nyo is absolute. So, iba, prepare na, in-examan ko ng ganyan. At ang dinalagay na temperature is 2027. Okay? So, kaya nga, nagtaka ako, pag prepare na, nakaabot siya ng prepare na yun ang ginagawa sa solution. Okay? First time siguro mag-solve. Where B sub D is equal to pi D squared ln over 4 is equal to pi times 0.355 meters squared times 0.381 meter. Ito yan. Okay lang yung automatic yan. Kasi di ka naman mali dito sa conversion. Pero pag ginawa mo itong 3.81, sa mali ka. So 150 over 60 revolution per second. Yan, RPM yan. Divided by 4. So displacement volume is 0.0943 cubic meter per second. This is the displacement. So, kailangan mo ng volumetric efficiency para makuha mo yung V1. So, di ba? I-discuss natin yung volumetric efficiency. So, ako doon sa ano. So, envelope G pala, compressor del refrigerant. Okay. So, this is N sub B is equal to 1 plus C minus C times P2 over P1 exponent 1 over N or 1 plus 0.05 minus 0.05 times 379 over 97.9 exponent 1 over 1.3 is 0.908. So B sub 1 is equal to 0.908 times 0.0943 is 0.0856 cubic meter. So bitot mo na yung value mo dito. So P1 is 100 times B sub M over 20 plus 273 is equal to 97.9 times 0.0856 over 27 plus 273. So B sub F is 0.0819 cubic meter per second. This is the free air capacity. Okay, this is now the answer. So review nyo to. Kami kong binibigyan yan sa final. At remedial. Next is introduction. Yun, ano na, ito is, hanggang dito is yung sa compressor plant. Compressor plant. Okay? Now we go to the pneumatic system. Introduction to pneumatic fundamentals. So may makikita naman kayo, pneumatic controls, iba yun. May mga symbol yun, iba yun. Ano yung instrumentation. That is pneumatic control. Instrumentation, yung pabigyan rin yung discuss to. Andun is yung mga sensors. Okay? So, kaya lang pag ma-encounter nyo first sa mga trabaho is yung pneumatics. Maraming types ng pneumatics. So the purpose of pneumatics is to do work in a controlled manner. The control of a pneumatic power is accomplished using valves and other control devices that are connected together in an organized circuit. So the starting point in this organized circuit is the air compressor, where the air is pressurized. Basta air, ang nasa loob ng pipe is pneumatics. Pressurized air. Okay? So, mga control valve system. So, ibang topic na yun. Dito tayo sa piping. So, Ito nga yung kanina sa cover. Yan. Yan yung pneumatic system. So the pressurized air goes to a air receiver. So, ang compressor, meron pa dito after cooler. So, yan, punta ng air receiver for storage. Hindi laging dapat under to. Ito yung yan. Ito na ang bahala sa air receiver para itong pressure tank. And then, is processed for use by passing through the filter. May filter sa dyan. Dryer, and in some cases, lubricators. Isa yung mga lubricate ng machines. Yung iba, di kailangan ng lubricant. This pressurized air is normally classified as instrument air. Yan. Ito mga looping. The air must be moisture and oil-free. Yung mga drips dyan. This air must be moisture or free to prevent control devices from plugging up. Kaya may mga filter. Yan. Figure 3 shows a typical compressor supply system. Tayo punta dito. So, pwede ka rin ganyan. Kasi ito naman auxiliary receiver, single heavy, intermittent fuse. So, pwede ka pa dito. Para ito naman, dito nagpapangsyon, pero ito nagpapangsyon dahil ang receiver dito na pressure. Okay? Pala kami sa design. So, ito naman yung mga outlet. Yan. Ito. Iyan ko lang. Pero isang mo yan, andyan yung mga ulit. Okay? Actually, makikita nyo yan sa mga shop. So the following describes the function of the system component. So compressor, siyempre, compresses the air. Pressure switch turns the air compressor on and off. So pressure. Pressure relief valve, release air pressure at 110% of the operating maximum pressure. This device is fitted to the receiver by law. Sa receiver sa nakalagay. 110. Ba't nga sa 150? Sa 150, yun na yung hydro test yun. Sa testing na yun. Hydro testing yun, 150%. Sa relief valve is mga 10%. Check valve permits the compressed air to flow away from the compressor and will not allow any air to return to the compressor. Air receiver. The receiver stores the pressurized air. By law, it must have the following fitting installed on it. Merong pressure gauge, pressure relief valve, pressure gauge, access, and hole. Kamay lang makapasok. Iba ang manhole. Ang manhole, tao nakakapasok. Okay? The drain valve. Pressure regulator controls the system pressure to the manifold. Ito yung manifold. Pressure gauge indicate internal pressure of the system. Must be fitted by law. Kasi meron mga calibration niya. Filter, this device cleans the air of dirt and contaminant. Lubricator, this device adds a small amount of oil to the air in order to lubricate equipment. Note, this is only installed when needed. Most systems are oil-free. Sa pharmaceuticals, mga clean room, oil-free yun. Okay, pressure manifold. This distributes the air to the various ports. Needle valve, control the airflow to the various systems that are to be operated. Okay. A compressor, for the compressors, a compressor must operate within a system that is designed to acquire and compress a gas. The system must include the following components regardless of compressor type. Meron tayong lubrication system. The lubrication system has two basic functions: to lubricate the compressor's moving equipment, a component, and to cool the system by removing heat from the compressor's moving part. While all compressor must have a lubrication system, the actual design and function of the system will vary depending on compressor type. Next, the lube pump. The oil pump is usually gear-driven. See the figure. Ang bigger pala is separator. The oil pump is usually again driven from the crankshaft so that it will start pumping oil immediately on start of the compressor. Yung driven, nakakonect siya sa crankshaft, nasabay siya. In compressor that works in an oil-free system, oil injectors are not used. Oil separators are installed on the discharge side after leaving the aftercooler. Ito, pumapasok dito. So, yung mga bubble cells, so nalalaglag yung mga oil. Dito, may wire mesh screen, so tatagal naman yung mga oil. Dito, malinis na siya. So, oil separator. The basic purpose of an oil separator is to clean the pressurized air of any contamination, which is highly detrimental to pneumatically controlled instrumentation. A separator consists of an inlet, a series of internal bubble plate, a wire mesh screen, a sump, and an outlet. The pressurized air enters the separator and immediately passes through the bubble plate. As the air impinges on the bubble plate, it is forced into making sharp directional changes as this passes through its bubble section. As a result, the oil droplets separate from the air and collect on the bubbles before dropping into the separator sump. So after the air clears the bubble section, it then passes through the wire mesh where any remaining oil is trapped. The relatively oil-free air continues to the air reservoir for storage. So wala yan. The air reservoir acts as a final. So the air reservoir has drain traps installed at the lowest point where any accumulated moisture oil is automatically discharged. As part of any routine maintenance procedure, this discharge trap should be periodically be manually bypassed to ensure that the trap is functioning and no excessive water accumulation is evident. Check. So, ito is mga part na ng compressor, auxiliaries. Compressor selection. So, air power pitch compressor generally operates at pressure of 500 psi gauge or lower. So, the pressure maano dyan is lower pala, yung gauge pressure pala yan. With the majority in the case of 125 psi gauge or less. All major types of compressor, that is reciprocating, vane, helical, lobe, and dynamic, are used for this type of service. Choice is limited somewhat by the capacity at 100 psi gauge. This is the 7 kilopascal, 7 bar gauge yun, of about 10,500 cubic feet per minute, but can be built to approximately 28,000 cm. Same yan, 10,500 cubic feet per minute at 28,000 cm. Ang yung cubic feet per minute sa cm, same yan, di ba? Okay. So, ulitin ko, yung 100 psi gauge is approximately 7 bar in gauge. Gauge yung bar na makikita nyo kanina. The main type rotary has an upper listed size of 3,700 cm as a twin unit, and the helical lobe rotary can be used to nearly 20,000 cm. So, meron tayong kanina pinakita ng selection. The centrifugal can be built to very large sizes. It is currently offered in the proven moderate speed design starting at a minimum of about 5,000 cm. Okay, next, safety valve. All compressed air that use a positive displacement compressor must be fitted with a pressure relief or safety valve that will limit the discharge or interstate pressure to a safe maximum limit. Most dynamic compressors must have similar protection due to restrictions based on casing pressure, power input, and or keeping out of source range. So, two types of pressure relief valves are available. We have the safety valves and relief valves. Although these terms are often used interchangeably, there is a difference between the two. Okay? Ito ang difference sa pagkailangan kayo. Safety valves are used with gases. Relief valves normally used liquid terms. Okay? The disc overhangs the seat to open additional flush area after the recent opening. This fully opens the valve immediately, giving maximum relief capacity. These are called pop-up safety valve. With the lip valve, the disk area exposed to overpressure is the same whether the valve is open or closed. There is a gradual opening, the amount depending upon the degree of overpressure. The lip valves are used with liquids, where a relatively small opening will provide pressure relief. Yeah. Positive displacement machines use safety valve. There are ASME standard of material sizing and only ASME stamp valve should be used. The relieving capacity of a given size of safety valve varies materially with the make and the design. Care must be taken to assure proper selection. So dito yung illustrate how a safety valve functions. Relief valve, safety valve, the mister, oil, after cooler, then compressor. Ang direction niya, galing sa compressor, after cooler, then ito yung oil, tapos safety relief valve bago pumasok sa receiver. Kasi dito mataas ang pressure niya. So coolers, and after coolers, binanggit tayong after coolers. Pero din yung intercoolers. So the moisture in compressed air system can cause corrosion, water hammer, and press damage. Therefore, it is important to avoid moisture in compressed air system. Coolers are used to address the problems by moisture in compressed air. Coolers are frequently used on the discharge of a compressor. These are called aftercoolers, and their purpose is to remove the heat generated during the compression of the air. The decrease in temperature promotes the condensing of any moisture present in the compressed air. So, condense, alis siya. The moisture is collected in the condensate trap that are either automatically or manually drained. If the compressor is of multi-stage type, there may be an intercooler, which is located after the first stage discharge and second stage suction. Alam itong intercooler, di ba? Intercooling sa compressor. Yan. Mature dyan. Hindi ko na ituro. The principle of intercooler is the same as the principle of intercoolers as a heat exchanger, and the result is drier, compressed, cooler, compressed air. The structure of the individual cooler depends on the pressure and volume of the air it cools. So figure 11 illustrates a typical aftercooler, a typical compressor air cooler. Ito is one pass. Normally, may makita ka sa mga site, makikita mo dyan, one pass yan ng air. Okay? Tawag yan one pass. Yung water, inlet, pataas, pababa. Bakit sa baba yan? Kasi pag tumataas to, so yung tubig mo, pupunuin niya lahat yan. Then out. Pag ito sa taas at ng ito, mawawalan to ng naman yung iba. Kasi diretso na sa baba. Okay? Nag-gets nyo bakit sa baba ang inlet niya. The combinations of drier, compressed air, which help prevent corrosion, and cooler, compressed air, which allows more air to be more compressed for a set volume, is the reason the air coolers are worth investment. This moisture is collected in condensate trap that are either automatic. Oops, nakomdoble. Sorry. Ang galing. Ang dami pang records. Okay. Piping system design. So piping layout on the plants will now be reasonably complete with checking for space, clearances, interference, insecure anchored drops to the equipment. Also, the following information must be available. 1. A list of all consuming devices. 2. Minimum and maximum pressure requirement for each device. 3. Actual volume of air used by each device. 4. Duty cycle or use factor. 5. Special individual air conditioning equipment requirements. Air conditioning equipment, hindi ito yung aircon na malamig, kundi yung regulator, filter, yan. So filtration is also air conditioning. So it will now be possible to start sizing the piping using the following 6 points. One, in order to use pressure drop table, so equivalent length, it is necessary to find the equivalent length to run from the compressor to the farthest point in the piping system. The reason is that the various piping pipe system pipe sizing table are based on a pressure drop developed using friction loss for a given length of pipe. Measuring the actual length is the first step. In addition to the actual measured pipe length, the effect of fitting must be considered. This is because fittings in valves create an obstruction as been to the flow of air. This degree of obstruction has been converted to an equivalent length in order to make calculation easy. Nandito yung mga equivalent pressure loss to valves and fittings in feet of pipe. Table 6 has been developed to indicate the equivalent pipe length for fittings in valves that should be added to the actual measured run to establish a total equivalent run. For preliminary calculation purposes, since wala ka pang pipe size, the addition of 50% of the actual measured run will give a conservative approximation of the total equivalent run, and therefore the means to select a preliminary pipe size necessary before final calculations are made. Ibig sabihin, pag nag-assume ka ng 50%, then select the pipe size. Pag nakuha mo yung pipe size, ulitin mo yung calculation mo based na doon sa pipe size mo, hindi na sa 50%. Okay? So now determine the actual pressure drop that will occur only in the piping system. So the generally accepted practice is to allow 10% of the proposed system pressure for pipe friction loss. So lahat yan. Diba? Kahit sa fuel, ano lahat. So that for a 125 PSI gauge, so X660 kilopascal, so makita nyo that this is 8.6. Balbong ng 100, 8.6 bar. Okay? System, a figure of 10 to 12 PSI gauge, 85 to 90 kilopascal will be allowed as a pressure drop. Since the air compressor has not yet been selected, this figure is variable. A smaller pipe size may lead to higher compressor horsepower. It is considered good practice to oversize distribution means to allow for future growth and also to allow for future addition of conditioning equipment that may add a pressure drop not anticipated at the time of the original design. So okay lang yung sa pipe size. Sa compressor selection, so doon ka dapat accurate. Mahal ang compressor. Number 3, size the piping. Size the piping system using appropriate chart for system pressure. Yung pressure drop of air. Having calculated the ECFM and the allowable friction loss in each section of the pipe being sized. Since all pipe sizing charts are formulated on the loss of pressure per some length of piping, usually 100 feet or 30 meters, it will be necessary to arrive at the required value for the chart you are using. The table 7 to 10% friction loss of air through schedule 40 steel pipe and PSI gauge per 100 feet at 50 to 125 psi line pressure. Use the highest system working pressure to determine pipe size. The temperature used to calculate the friction loss is 60 Fahrenheit. For 100 Fahrenheit, increase pressure drops figure in tables by 7.7% for greater accuracy. For copper pipe, reduce pressure drop figures by 5%. The maximum of velocity of 4,000 feet per minute or 20 meters per second is recommended. Yan. Maximum velocity. Ito yung 50 PSI gauge and 60 Fahrenheit. This one is 75 PSI gauge Ang value nito is CFM standard. Free air also called standard CFM. Okay? Which is now 100 PSI gauge pressure, 125 PSI gauge pressure. Kung saan katitingin ang value niya. So, pipe sizing table. So, discharge were calculated using the following formula, using IP units, English. So, sa design natin, gagamitin natin ito. Tingnan natin. Put ko na. So, delta P per 100 foot is gamma F B squared over 2 GD. So, delta P per 100 feet is the pressure loss due to friction, PSI per 100 feet of pipe. F is the friction loss factor. Use 0.02 as an average figure. So, meron ka na. So, B is equal to velocity feet per second. G is acceleration due to gravity, 32.2. D, pipe diameter in feet. And gamma is the specific weight of A. Now, the following general design parameters can be used for miscellaneous device as a guide when calculating the total pressure drop of the piping system. So 1, equipment drop leg is 2 PSI gauge loss. So drop leg, papunta dun sa equipment mo. Sa outlet. 1 PSI gauge impossible. Hose allowance, kakabit ka ng hose, ang pressure drop is 2 to 5 PSI gauge. Quick disconnect coupling is 4 PSI gauge. The lubricator, 1 to 4 PSI gauge loss. Point of use filter, 1 up to 2 PSI gauge loss. Ito yung average mo, pwede ka na mag-assume ng loss na. Diba? Kung meron kang pressure drop na kailangan sa pinaka-final mo, i-add mo lahat to, plus yung losses sa pressure, losses doon sa main pipe. So this is now yun na magiging pressure doon sa receiver mo. Okay? Then, operating pressure mo, ang compressor is your average is dapat same sa receiver. So now, ito naman, estimating compressor system pressure drop. So, compressor operating range, 105 to 105 PSI gauge. Filter regulator, lubricator, ito yung pressure drop, 7 PSI gauge to. After cooler, 3 PSI, filter 3. Air lubricant separator 5. Hose and disconnect 4. Yan naman. Dryer 4 PSI gauge. Distribution system 3 PSI gauge. Pero ito, kailangan mong i-verify through calculation ng pressure losses. Okay. Supply, ito yung demand. Example. Regulated end use is 70. Ito. Dito siya. So, 76. Ang required mo, so madagdag ka para dito sa mga hose valve, filter regulator valve hose, disconnect pressure drop, magiging 87 after dito sa distribution system. Then, doon naman bago naman doon kasi bago sa pumasok sa distribution system, nadaan siya sa dryer, sa filter. Ito. So, yan, 90. So, before pumasok naman ng after cooler, galing sa compressor o receiver. So, ito yung maintain ng receiver mo. So, this is now the operating range ng pressure maximum. So, minimum mo dapat makomplete ang pressure natin. Estimate lang to, estimate. These are approximate. So, pag meron kang available data na mas iba dito, ayun ang gagamitin mong equipment. So, yun ang gagamitin. So, kung hindi naman, design ka lang. You can make this as realistic value. Huwag mong sambahin. Walang reference. Huwag mong sasambahin kasi wala naman kayong reference. So, table 11 gives deflection loss of air through hose that would be used to connect tools to the main piping system. So, instead nitong estimate, so dito yung value. So, ano yung length ng hose mo, so pwede mo ma-verify. Kung less than 4 siya, so okay. Kasi meron kang basihan. 6 feet, ito yung 6 feet hose. Ito yung size. Ito yung flow rate. So, this is now deflection loss. So, iba, di ba? Double check mo. Kung mas malaki, so itong gamitin. Normally, nag-average siya sa 4. Filters. So, later na to. Part 2.